All right, so we got this function right here, f of x equals log base 2 of x minus 5 altogether right there that we need the graph for, and we need the domain and the range. So first thing we're going to do is kind of rewrite this in exponential format. I think that's going to help us. So the f of x, though, I'm going to change that into just a y, just so it doesn't look so funky. We're going to show this as a y. Okay, now changing this into exponential form, we have over here a base 2. So it is going to be base 2 to the power of what the log equals, which is y in this case. And then would equal the inside of that parentheses, whatever it's the log of. In this case, it's log of x minus 5. And then the last step here, in order to make this look pretty anyways, is we're going to take that x minus 5 and just kind of move that minus 5 over. So let's go ahead and do that. So that just means I would add 5 to both sides. And to make this look decent anyways, we're going to show it as 2 to the power of y plus 5 is going to equal that x right there. Now, this is going to be a little bit different for us in terms of making a table, because we usually choose values of x and then find corresponding values of y. But in this case, we're going to need to choose values of y and then find values of x. And if you're like, why is that the case? It's because all of our operations are being applied to the y. Now, we should start, of course, with, well, probably start with 0 right there. 0 is a nice number to start with. Now, you could put this in the calculator, but 2 to the power of 0 is 1, and then plus 5 is going to give us a corresponding value that is 6. And that right there is our x-intercept at 6, 0. So that's going to give us this point right there. And then, what the heck, let's just try 1 as y. So up here, we'd have 2 to the power of 1, which is 2, plus the 5 is going to make that a 7. So it's going to be 7, 1, which is going to be this point right there in green. And then next up, we're going to try y value. Let's just try 2 and see what happens there. So 2 to the power of 2 is 4, plus 5 there is going to make an x value. That is 9. So we got 9, 2 right there. And we see it's not straight, right? It went up 1 to the right 1, then up 1 to the right 2. But let's see if we can find some of those other values. Okay, so I have some y values that are positive. And just as a quick gimme on this one, if you made the y value a 3, then you'd have 2 to the power of 3, which is 8, and then plus the 5, which is going to be 13. That's off our graph, so I can't actually put that on the graph. But next up for us, let's try a y value that is negative 1. Let's try some negatives. Okay, so that's going to be 2 to the power of negative 1, which is 1/2 plus 5. And to show the decimal on that one, it's going to be 5.5. Okay, so that's approximately by hand. So 5.5, negative 1 is about right there where that red dot is. Okay, now we see it curving downwards, which we expect, but let's try negative 2 instead. So 2 to the power of negative 2 is 1/4, plus 5 is going to be 5.25. And again, you can use a calculator for these stuff. You don't need to do it in your head like I'm doing right now. But 5.25, again, it's going to be hard to show the difference there, but 5.25, negative 2 is about right there where that blue point is. Okay, now we see it's getting very close to this asymptote. And let's see if I can show that on here. This asymptote right here at 5. Why is it getting close to that asymptote at 5? It's because remember here we have the x minus 5 right there, which means it's moving the graph 5 units to the right, which is here. And we can get this 2 to the power of y really close to 0, but we'll always have that 5. But it'll never actually equal that 5 because this value can never actually equal 0, which means that we should be able to put this on the graph. Let's do this in black. So we're going to get, see if I can do, that's not my worst. And then that's to the right, and then, yeesh, it's kind of hard with this electronic stuff, but I need to show that it's getting really close. Hopefully yours looks a little bit more steady than mine, but I'm going to stick with that one right there, and that is our graph. Excuse me. Okay, so where did the graph come from? Again, I know it's going to get really close to 5, but it can't actually ever equal 5. So be careful that your graph isn't showing something like this, especially if you're doing it by hand, because it can't go past this asymptote at 5. So you need to make sure you don't do that, especially if it's on an exam. Next up, we need the domain. So the domain, we want this in interval notation. And we see that it pretty much starts there at the asymptote at -5, but it's not actually included. So we have a parentheses right there. And again, that's because this can never actually fully equal 0. It can be really close to 0, but not 0. And then you got the 5. So it never actually ends up being 5. And then it will go all the way, we see that black arrow to the right, all the way to infinity. So if you're like, well, why is that? Because we're looking at x values for our domain. And then the range, of course, is going to be our y value. So how far down does this graph go? Well, it goes all the way down to -infinity. And of course, the infinities are never included, which is why we got parentheses. And this one does go infinitely up, even though it looks like it's kind of bending straight right here. That's not true. You can find a y value that will work as far up as you want to go and as far to the right you want to go for your x's. So there is no restrictions on the y values. It goes furthest down as you can go, and again, just based on how I drew this, it doesn't look very good, but it will go as high up as you want it to go as well. So these are the answers we want. We got the graph, and then we got the domain and the range.